Parabolas, looking at the 10A part of this course. So we are starting out by looking at what is called the turning point form of a parabola's rule. A quick reminder that as you've been looking at the transformations that happen with the various parts of the rule of a parabola, A in y equals ax squared dilates the graph. So an absolute value, ignoring the negatives, of a that is 1 or greater than 1 will make our graph steeper. Between 0 and 1 makes our graph shallower. And of course, if a is greater than 0, our graph is concave up with a minimum. If a is less than 0, that is it's negative, our graph is concave down with a maximum. If we have b in our, so bx is not b is not 0, and we could factorize into this form, then h in x minus h all squared translates the graph horizontally. Now you will see that we've actually got x minus h. H itself is separate from that negative. So if you see x minus 2, then h is positive. If you see x plus 2, then h is negative because this minus is there, so h must be negative to see a plus 2. If h is negative, we'll start with positive. If h is positive, so h is greater than 0, then we move h units to the right in a positive direction. But if h is positive, we're going to see a minus there. If h is less than 0, that is h is negative, the graph will be moved h units to the left, that is in a negative direction. But of course, if h is negative, x minus h will mean that we see a plus here. So it's a little bit hard to think about, but it's based on the fact that when we see a negative, we shift positive, which I'm sure you've already observed. And k, of course, translates our graph vertically. And this one's nice and easy. When k is greater than 0, we move k units up. And when k is less than 0, we move k units down. So that's how our graph gets translated. Now this all combined together makes the turning point form of the graph. And we will come back to getting a graph, a parabola rule into the turning point form. You might already have worked out how, but V, the vertex or the turning point, is given by hk, x and y values of the vertex, and our form is y equals a outside of x minus h squared plus k. So you can see how much we're moving up, where the turning point is, and from A, you can see if we are concave up or concave down. So if we're asked to sketch a parabola from the turning point form, this is y equals x minus h plus squared plus k. So since our turning point is hk, now be careful, h is 3. So our x value of the turning point is 3, because even though you see minus 3 in here, remember that it's x minus h. So if you see a negative 3 in here, that's because h itself is here and it's positive. K is nice and easy, no confusion there. Negative 2, so the turning point of my graph is 3, negative 2. Once you've got the turning point, you can substitute in x equals 0 to find the y-intercept. So you have your rule, substitute in x equals 0. I've got negative 3 squared is 9, minus 2 is 7. So I've got the y-intercept. I know because it's also a good idea at times just to have written down a is 1, h is 3, k is negative 2, if you feel like it. A is 1, it's positive, so I know I'm concave up. So then to sketch based on that, preferably use a ruler at this point. Draw your little axes, x and y. And I have a turning point at 3, negative 2, so put 3, negative 2 somewhere where it looks meaningful. And I've got a y-intercept at 7, and you sketch your parabola as symmetrically as you can based on the y-intercept and the turning point, and you label it. So sketching a parabola, if you're asked to use the turning point form and it doesn't ask for the intercepts, I wouldn't give it, but we could work out the intercepts as well, and we'll come back to that. Sketching using the quadratic formula, of course. If you've got the x-intercepts, you can sketch very easily. And you can get the x-intercepts by solving, by factorize, null factor law, and solve that way, or by solving using quadratic formula. Now, in this form, in the general form, of course, our y-intercept is y-intercept. So that's at 0, negative 3. You may like to check using the discriminant how many x-intercepts you're going to have, how many solutions there are, because it's a quick check, and that way you know if you're looking for 1, 2, or 0 intercepts. So B, now remember, a good idea to list A, B, and C. 2, 4, and negative 3. 4 squared, I've got 16. Minus 4 times 2 times negative 3. 16 plus 12. So, okay, fine, that's 28. The discriminant is positive. Or you could, of course, write that. Therefore, 2 intercepts. Okay, so I know I'm looking for 2 x-intercepts. Solve using the quadratic formula. Now, of course, this is going to come out with exact values, and I didn't put it in the question, but we're going to 2 decimal places here. Notice when you get to here that you can simplify your surd. So that's negative 4 plus or minus 2 outside of root 10 on 4. We can simplify here because I've got a common factor of 2. That's negative 2 plus or minus root 10 on 2. Type that into your calculator in both different ways, and x is, well, technically that's approximately 0.58 or negative 2.58. Now, remember the quadratic formula solves. If you were solving and you factorized, So y equals x minus 2, x plus 3. You remember you change the signs to get your intercepts because you use the null factor law, x minus 2 equals 0, therefore x is 2. But when you're using the quadratic formula, you are not using the null factor law. It is solving for x for you, so these are the intercepts. Don't go switching the signs. Once you have your x-intercepts, sometimes you'll also want to put the turning point. To get the turning point, find your axis of symmetry. X is negative b on 2a. Negative 4 on 4, x is negative 1. Sorry, I'm getting a little messy there. And substitute x equals negative 1 into your rule. Sorry about the bell there. That's 2 minus 4 minus 3. So y is negative 5. So I've now got my turning point at negative 1, negative 5. I've got my x-intercepts. I already had my y-intercept from the rule. Everything's great. And all of those can go on a set of axes. Remember also, you're okay to make the axes not symmetrical if you know you need to be graphing over in the negative range. Little arrows, label x and y. Incidentally, if you want, put in your turning point roughly where it should be. So negative 1, negative 5. And then it's easier. Just work out roughly where your y-intercept should be. Okay, it's negative 3. And there's going to be an intercept over here and over here. And you can draw your parabola and then mark in the points. Because we're just sketching. And you'll have noticed from the last one I did that it's harder if you try to put your points in and then sketch a parabola to fit it. This way, it's properly sketched and you're not dodging around trying to get to your points. Okay, I am aware this one's long. Completing the square. So sketching using the turning point form, and this is how we get our parabola's equation into the turning point form. You start by completing the square. So you remember we want our old friend b over 2 squared. That will be 6 over 2 squared, that's 3 squared, which is 9. Use that to complete the square. Y equals x squared plus 6x plus 9, close your bracket because that's a perfect square, minus 9, and don't forget your plus 15. Factorize your perfect square, which uses the number inside the brackets, x plus 3, because that's positive, squared, minus 9 plus 15 means plus 6. It's worth noting that we're now in turning point form. A is obviously 1, it's positive, good. H is negative, and K. Because A is positive, and because this is positive incidentally, there's no solution to this. So we're not expecting any turning points. If there was a solution, we'd want to get the turning points, probably with exact values, because we had to complete the square. But we can see there's no solution. I'll come back to why there's no solution in a minute. Our turning point is HK. H is negative, because this is x minus h, so for this to be positive, I need to see minus negative 3. K is 6. There's my turning point. Once you've got your turning point, find your y-intercept. Let x be 0. So substitute into the rule. Oh, we had a y-intercept anyway. This is the y-intercept. But if you forget that, like I just did, then y equals, well, that's 0 plus 0 plus 15, which is why the y-intercept is 15, and I could have got it from the rule. Sorry. Find the x-intercept. Now, the x-intercepts are at y equals 0. 0 is x plus 3 squared plus 6. There is no solution, because for this to equal 0, this would have to equal negative 6, and there's nothing that I can square to get a negative, so I can't get any solutions. No solutions, so there are no x-intercepts. You could check with the discriminant if you weren't sure about there being no solutions, and the discriminant would tell you that there's no solutions. And then, of course, you sketch. I know that A is positive, so I know I'm going to be above the x-axis and not coming through the x-axis because there's no solutions. My turning point is at negative 3, 6. My y-intercept is at 15, and again, I'm just going to pop in a dodgy parabola and say that's 15, because that's good enough. I have sketched it and shown the salient points. Okay, man, longest video ever. Finding an equation. Now when we're finding an equation, we might be given the x-intercepts and one other point. So here I've got the x-intercepts and the y-intercept. Here I've got the x-intercepts and a turning point. It all depends on what have you been given, whether you want to use the turning point form or the factorized form. There are various different options. So this one I'm going to use the factorized form. Y is A outside of X and factorized. Now obviously, because my x-intercepts are 3 and negative 4, in the brackets I'll have plus 4, excuse me, opposite of that, minus 3. Now, that would, just having the x-intercepts would draw me all sorts of equations, because here's negative 3, here's 4. I could have anything. I could have a graph that looks like that, or like that, or like that, whatever. So you do need one other point apart from the x-intercepts, and we have to work out A. We have another point, so we're going to substitute that in to find A. I've got the point 0, 48, because that's the y-intercept. Substitute that in here. 48 equals A outside of x 0 plus 4 and 0 minus 3. So 48 equals negative 12A, so A equals negative 4. So my rule is y equals negative 4 outside of x plus 4, x minus 3. Or of course I could expand that out if I preferred, and so expand this and then multiply by negative 4, negative 4x squared minus 4x plus 48. And checking, 48, 48, I should get that because that has to be the y-intercept. One more example, if you want it. A parabola has these x-intercepts with a turning point at 2, 4. Find the equation. Now I could just work out the factorized form and substitute this in to find A, but I could, which I'm going to show you, use the turning point form. Substitute in h and k. So y equals a outside of x minus 2 squared plus 4. And then substitute in one of the other points. I'm going to take 0, 0 because it's easier. 0 equals a times 0 minus 2, negative 2 squared, plus 4. That's 4a plus 4, so 4a is negative 4, a is negative 1. So I've found a. So I've now got my rule in the turning point form. Y equals negative 1 outside of x minus 2 squared plus 4. I've got the turning point form. If I preferred, or if the question asked, I could expand this out to get the general form. So that's y equals negative x squared minus 4x plus 4 plus 4. That means I've got y equals negative x squared plus 4x minus 4 plus 4 cancelled. So I've got my general form. Sorry, I'll move that way you can see it. And if you preferred, you could give it in the factorized form. Y equals negative x outside of x minus 4. So it does depend on what you want when you're giving the equation and what the question has asked for. If they just say find the equation, generally either the turning point form or the general form.